Alrighty, it's time for algebraic proof day 3, which is just section 2.4 day 3. It's really algebraic proofs day 2, but you know, it's all gravy. So we're going to just go ahead and use algebraic proofs to start moving past actual proofs. Okay, so let's do one more algebra proof to make sure we're good. Make sure you write your given, negative 4x minus 3 plus 5x is equal to 24. And then the reason is given. Okay, that's always what you got to do first. All right, after we've done our given, we've written our given down. I want you to go back to this from the second day and look over all those again. Pause and make sure you're gravy. Same thing there. So, ladies and gentlemen, how do we solve? Well, clearly we're going to distribute. So I would have a negative 4x plus 12 plus 5x is equal to 24. And then remember, in the second one, we always put our reason, so distributive property. All right, the next, we're going to combine like terms because these are on the same side. So I get x plus 12 is equal to 24. And that's a math fact. Remember, anytime we do something like adding, subtracting, when they're on the same side, we just call it math fact. You can call it simplify if you would like. Then we'll move that over, and I'm going to get x is equal to 12, and that was subtraction property of equality. Remember, you have of equality. Make sure that's always in there, okay? It's not right unless you have it. Okay, so now we're going to move into our, technically our algebra proofs, but we're going to throw in some geometry. So this is our given here, is that AB is congruent to CD, and that's given. So the first thing you always do with your proofs is write your given. So we did that. Check. The second thing you're always going to do, so if I write this right here, given, step 2, is you're going to label your diagram. So I know that AB is the same as CD. Put my little tick marks there. Cool. And then I'm trying to prove that x is 7, okay? So that's always going to be your last step. So some people like to just go all the way down here and put x equals 7, because technically that's going to be our last step. You can, but as long as you know that that's the last, you're good, okay? So, ladies and gentlemen, let's go ahead and move forward. So, do you see how all this information right here has numbers in it? Well, the only time we can use numbers in segments is when we make an equation. So what we're going to do is we're going to go from congruence to equals. And the way we do that is called the definition of congruence. That's not an of, excuse me, of congruence, or congruency, some people call it. We're just going to write this as defin of congruence. So this is going to be one of the most important things that we do today, is that anytime you go from congruence to equals, like we did here from step 1 to step 2, okay, that is going to be the definition of congruence. Get used to that. You write that sometimes 2 or 3 times a proof. It is super basic. It's super easy, but it happens all the time. So star that. Okay. Alrighty. So what's next? Now that I know that AB is the same as CD, to solve, I just need to plug in their values, right? I know that these are the same. I had the tick marks there. So plug it in. So what did you do right there? That was just substitution. So now we're going to solve. So I would add 4x to both sides. And so that's addition, property of equality. And then I would divide to get x equals 7. And that's the division property of equality. Oh, forgot my prop there. Alrighty. So, ladies and gentlemen, we wrote our given, we labeled our diagram, and then we know what we have to prove because that goes at the end. That is the most important start to a proof that you can do. Okay. Now the rest, all this stuff in between, is just going to take some time and some practice. You're going to get to realize that there's some patterns that go along with proofs, especially with segment proofs and angle proofs. So once you get the habit of those patterns, life is going to be okay. But today we're just trying to get used to some of these basics. The most important being this step right here, going from congruence to equals. Okay. So ladies and gentlemen, let's go to the next one. So right here it says that DF is the same as EG. So we put our tick marks there, write our given, DF congruent EG, given. And then we say, hey, if they're congruent, that means they have the same measurement. So DF is equal to EG. And if they have the same measurement, we can actually do mathiness with it. So this was the definition of congruence. Anytime you go from congruence to equals, definition of congruence, and I'm not going to lie, you go from here to here a lot. So get used to it. So the next we're going to substitute numbers in. So DF is 11, and then this is 2x minus 9. And that's just substitution. We're just plugging stuff in. Alrighty, now we're going to solve. So I would add 9 to both sides, so I get 20 is equal to 2x. And that's the addition property of equality because we're adding to both sides. Then we're obviously going to divide. So 10 is equal to x. Now, ladies and gentlemen, let's pause here to make sure we're gravy. Some of you might even be working ahead, which is awesome, but hold up. That's x equals 10. This is 10 equals x. They don't look exactly the same. It's implied that they're the same, but they don't look exactly the same. So this is when we need to have our good old friend, the symmetric property. So x equals 10 is going to be our symmetric property. And I'm running out of room there a little bit, but that's okay. So what's important to note is that these right here have to match, and I'm talking 100% match. Not implied matching, 100% match if this is going to be true, okay? If you don't do that last step, you're running a race, and then right before the finishing line, you're stopping and saying, yeah, that was fun. So, ladies and gentlemen, boys and girls, please, please, please pay attention to that fact. All right, example 4. Now, example 4 is a little funky. I have no diagram, and I have 3 givens. So each given gets their own spot. But I'm going to write them in the same color since they're all given. Even though technically they're not written in the correct manner, we'll let it slide. All right, given, because I have 3 givens, okay? So I'm going to prove that A is equal to 90, so we'll get there. Now, I notice that I have a congruence, so I need to use that, so I'm going to say the measure of angle A is equal to the measure of angle B. Notice that I changed it from congruence to equals, so that's still the definition of congruence like it always is. All righty. So now, ladies and gentlemen, boys and girls, I could say, all right, if they have the same measurement, then look, I can go ahead and plug something in. So if C is the same as 45, I'm going to say, all right, the measure of angle B is equal to 2 times the measure of angle C, and C is 45. Okay? So basically, I took this information and I plugged it in right there. So that is substitution. So then I'm going to be left with the measure of angle B is equal to 90 degrees. And that's just a math fact. And why is that helpful? Well, I said right here that A and B were 90 degrees. So if B is 90, then A is 90. So I'm going to say, okay, the measure of angle A is 90 degrees. And that, again, is substitution. I had to write it down here because I'm running out of space. Cool. So, ladies and gentlemen, welcome to Proofland. Now, this was baby steps to make sure we are all gravy, okay, with our proof in the algebraic form, okay? When we get back, though, in our next video in 2.5, part 1, that's when we're actually doing real proofs. But if I were to say the most important thing from today is this definition of congruence step right there, okay? We used it in every example today, and we'll use it in the next video, at least to an example, okay? So have a great day, and we'll catch you next time.